In order to understand the Cronk-Nicholson method, let's just consider this example. We let R, which is the value of k over h square, be equal to 1. In fact, we let h be equal to 0.2 and k equal to 0.04. Moreover, we assume that the following initial condition, u of x 0 is equal to some function f of x, which is equal to sine px. And we consider the case when t is between 0 and 0.2. In addition, we know that we have the boundary conditions u equal to 0 and u equal to 0 on both sides. So now we are going to write the discretization equation on both of these unknown. Let me just write this, show you this figure once more, where we have written all these unknown node points. We know these green points are known because it's on the boundary or they are initial conditions. So here on this x-axis we know the value of u, because it's equal to sine pi x. And on these boundaries we know also the function because it's equal to 0. We therefore start with this first row of unknowns. These 4 unknown values must be found. And we write the Cronk-Nicholson scheme once more. In the case when r equal to 1, it takes the following form. So let's start with this point. I equal to 1 and j is equal to 0. So, well, it's in fact in order to find the relation between these 3 points, we have to start with j equal to 0, and we just write the equation in this case. Instead, just put I here equal to 1 and j equal to 0, and then we obtain this equation. And now we must identify the values of u which is known. For example, the value u01. u01 is a value at this point, and it's known, it's equal to 0. So why don't we just write 0 here? This value u20 is the value here, which we know it's assigned to pi. So it's on this point it's signed to pi 0.4. I pointed to the wrong node. Sorry, and this is u00, and u00 is this value, and it's of course equal to 0 because it's a boundary point. So then we have this first equation. The second equation, for the second equation we write I equal to 2. So we now have, in the first equation we have the relation between u11 and u21, but we cannot solve the equation unless we have more information about it. So we need this second equation, which is obtained when I is equal to 2. So put I equal to 2 in this Cronk-Nicolson discretization scheme, and we obtain this equation. In this case, none of these values are known because its interior point is red points, not green points. But both of these points are known. This is sine to 0.6 pi, and this is sine to 0.2 pi. Okay, then we have the second equation. The third equation is all these for all these equations we write j equal to 0 because we must start on the lowest row, and we write here the final equation for I equal to 4. Then we obtain this. And now on the right hand side we know one of the unknowns. It's not an unknown, but it's a boundary point. It's u5 is u51 is equal to 0 because it's the value here. Other two we don't know. U50 is the boundary point here, so it's equal to 0 also. And this value here is sine to 0.6. So it's u30, it's sine to 0.6 pi. So this gives us 4 equations, and we have 4 unknown variables, so it fits very good. It's this variable, this is the same as this, but we have this. This is the same as this, so this is we have now counted 3, and here is a 4th unknown variable. So it's easy for us to solve this. When we have solved this unknown, we know all the values on this line, this row. So then we can start by the same procedure once more, putting j equal to 1 all over here, and find the unknowns in these 4 points. So in this way we are going to find all unknowns in the interior of the domain for our solution.